This is our second problem on Marshall mix design. In our first problem, we learned how do we calculate percentage of void of air, percentage of void uh, of mineral aggregate, and another one that was void filled with asphalt. So we'll find that again, void filled with asphalt. So you can find that for that the formula is you just multiply 100 with vm sorry vma subtracted by va over vm. So in this case this is vma, this is void of air. So you can find these values. So that would be somewhere 71.8, that would be 79, and later one would be 89.99, it would be 94, and this thing would be 94.37. So we have six criteria. One is unit weight, the other one is Marshall stability, we have Marshall flow value, we have void of air, we have a void of mineral aggregate, and we have void filled with asphalt. So these are the six criteria, and you have some little bit of data, information, that is the maximum size of aggregate was 1 inch, and for that your BMA percentage should be 13% as minimum. So BMA should be a minimum of 13% for your optimum asphalt content. So we are asked to find out optimum asphalt content, and and there is a question that is the mix satisfactory or not. And another question is, if not, what adjustment may be suggested? Assume reasonable values of missing data. Fine. So the thing is that we will first of all, the first thing first, that is we'll draw a curve for bitumen content versus percentage of air voids in total mix. From that, we will find bitumen content for 4% air void, and that bitumen content we will try to claim that this content of bitumen or percentage of bitumen is optimum. And to prove that, we will check other five criteria, that is unit weight, Marshall stability, Marshall flow value, and VMA and BFA. If the other five criteria are fulfilled, then we can claim that the bitumen content for 4% air void is optimum. If not, then it's not actually. So let's draw them. So this curve has been drawn for uh, percentage of air voids of total mixture volume, and you have asphalt content over there. So first of all, what we will do, we'll find out uh, asphalt content for 4% air void, and that asphalt content will claim that it is for optimum asphalt content. So it will come over here, and let's claim that the amount of asphalt here is it's 4 and 5 in middle, so it would be more than 4.5. Let's say it is 4.65 percentage of bitumen, and we'll claim that this percentage of asphalt content as optimum if other five criteria are fulfilled. So the second criteria is BMA percentage. So we'll find BMA percentage for 4.65 uh, percentage of asphalt. So let's say 4.65 is somewhere over here. So for that, we'll get a value like that. So it is more than 15%. Let's say it is around, let's call it is 16%. It would be, no, it should be 15.5 and below. So let's call it is 15.2%. BMA is 15.2%. The third criteria is BFA. Let's draw a line for 4.65. It should go all the way like this. And for that, we'll get a value of 70 and up. Let's call that 74 percentage. The other criteria is stability. We'll find that for 4.65%. And the value is above 1600 and less than 1800. Let's call that around around 1700, 1700 pounds. Uh, it should be more than 1700 actually. It should be around uh, 17, well, 1750 or 1725 or even. Well, the another criteria is flow value. We'll find flow value for 4.65% optimum bitumen content. We are trying to say this. So it's around a 9. Say this is 9.2, maybe 9.2. Now unit weight. Let's find that out. Unit weight for 4.65 percentage. So it should be somewhere over there, and maybe the value is 152, 152.5. It should be around 152 point, 152 point, let's say 3, maybe 3. So now we'll compare these values with the standard values. So if we consider our pavement is for heavy traffic, and the blow and for heavy traffic the blow is 75, and for that we need an stability of 1800 pounds minimum, but we got an stability of what, we got an stability value of 1700 or maybe 1750, but which is less than 1800, so it's not okay. Okay, so the design is not okay for the criteria stability. Okay, let's find the next one. Let's go for flow value. So we need a minimum flow value of 8 and maximum 15. So 8 to 15, sorry, 14. And we got a flow value of 9.5. So minimum is 8, max is 12. So okay. So the design is okay for flow value. Okay. The next one is percentage of air voids. For air voids, we need a minimum value of 3 and maximum value of 5. Where is air voids? Well, our air void is in this case 4%, which is in between 3 to 5%. So It's okay. The next criteria is percentage of voids in mineral aggregate, which is BMA, and it was told that the BMA should be 13% in question. But if you want to find out yourself, we had a maximum nominal maximum particle size of maybe it was 1 inch. Yeah, it was 1 inch, and for 4.65 it should be around 12 and 13. And in question it was said that it should be 13, but yeah, but if you compare it with the standard, it should be around 12.65 or 12.7, like that. So let's say we are taking the value of BMA as per the question. It was told, so it was said that the minimum value should be 13% and maximum is not defined. So it's greater than 13%. So it's okay. So BMA is okay. So now the end criteria, that is BFA. So BFA should be in between 65 and 70. So BFA should be in between 65 and 75%. So in our case, it is 74%. So it is okay. So the design is satisfactory for five criteria, but it doesn't satisfy Marshall flow value. So we can say that the optimum content for this design is 4.65%, and it should be adjusted uh, a little bit for Marshall stability value. Is the mixed design satisfactory? It is satisfactory for five criteria, but for one criteria, Marshall stability is not satisfactory, and should be adjusted for uh, Marshall's stability value. And for other criteria, it's okay, and optimum content can be said that it is 4.65%. So, if you know the values of the parameters, then you draw them. Yeah, you get the values for optimum content of between percentage. From there, you compare with the standard, and then you can say that the optimum between percentage is that much.